I'm here with Ken Puckett from Laser Product Safety out of, Ken, where are you from out there? You still out of the?
We're in North Carolina, just about 20 minutes from RDU Airport.
Well, first, I just want to thank you for all your help here with our team. It's been an absolute eye-opener, a pleasure, and just so helpful. Laser compliance and laser product safety, both from the manufacturing standpoint, what a manufacturer needs to do to bring code compliant lasers into the United States as an OEM manufacturer, laser safety, but also in safe facilities, safe practices. That's the other half of it. And from my perspective, I think that lasers are not sold as tools. They should be sold as programs. And with the FDA and what we understand about Class 4 lasers in the U.S. and so to approach it that way is probably the right thing to do. But tell us a little bit about what you do at Laser Product Safety.
As you know, lasers are found in all different categories of equipment: medical, research and development, construction, dentistry, just audio, video, communications, telecom. They're found in everywhere. And so what we do at Laser Product Safety is we assist manufacturers of these types of laser-based products.
Consulting framework?
So we're actually a third-party neutral test lab.
Yeah.
Where the manufacturer will have to prove that his laser product meets published safety requirements.
Okay.
Via a report, a technical report. And he cannot do it himself. He has to go and get a third party to do it. So that's what we do. But yeah, I like what you said there. A lot of times, a lot of lasers products can be just sold as a product, and the user can use it, relatively safely. But in what you guys are working with,
it's a little different, isn't it?
Yeah,
it's not quite what we're seeing in YouTube or what we should be seeing out there.
Yeah, these laser cleaners are, they can be dangerous if not controlled by what's required by the standard ANSI Z136.1.
So ANSI is the governing body. For those that don't know, ANSI is tell us a little bit about how they would.
How it works is the federal law of the United States is the OSHA Act, and what the General Duty Clause of OSHA says. A manufacturer must comply with any national published standards for whatever industry he's working in. And laser product manufacturers must comply with ANSI Z136.1.
And who's considered a laser manufacturer? There's a lot of imported lasers coming in.
Yeah.
So,
well, if a company here in the United States purchases a laser product that's manufactured in China, the Chinese manufacturer would be considered the manufacturer, and the company selling the laser in the United States would be considered the applicant. If the company in the United States chooses, they can buy it in pieces and assemble it here.
Got it.
And they become the manufacturer.
Right. Okay.
So there's ways,
But either way, they need to meet our standards. And who writes the standards for laser safety or laser product safety? What's the governing body there?
Well, here in the United States, the laser safety standard is ANSI Z136.1, and the 21 CFR Subchapter J, Part 1040.
What is the FDA?
That's the FDA standard.
Got
they
it.
work hand in hand, and it's basically a group of experts that meet and discuss the standard and write the standard.
Okay.
And they have to keep it updated. So I serve as an expert on the ANSI committee here for the United States. So I help write the series of ANSI standards.
And that's right down to the equipment of what the builds we were talking about, proper labeling. We were talking. Does it fall into that category of?
Yes, every type of engineering control that's required is discussed and
So
written
that's
up in requirements.
When we say there needs to be a redundant interlocks or how that system fails. We were talking about different things, tooling on keys to the the casing, how the labels look,
That would be
emission indicators. All of that falls under ANSI.
Yeah.
All right.
That's right. Now, outside of the borders of the United States, the laser product safety standard is IEC 6825.
Okay.
And this is, this is what the whole world uses. So it's kind of like, the United States is, we have our own.
So we're kind of off, but
Yeah.
do they cross over reasonably well?
There's some harmonization. There is some harmonization there, but they're never going to adopt the United States is never going to adopt the IEC 6825 flat out. So I'm on that committee. That's called the IEC TC 76, and I'm a delegate, a United States delegate for that committee.
Got it. And that group gets together and discusses those.
We show up as a group of United States delegates, and it's kind of like a small United Nations.
Yeah.
You got the other delegates, the Japanese, the Germans, the Italians, the British, and we all sit around and we keep that standard up. So that's where the standards come from. And they're always having to be updated and amended and changed. And, you have to bridge the gap between new technology and the standard, right?
Yeah.
That's one of the things that makes it a little challenging when, you have a technology that's been put out and there's no safety requirements written for it.
I think that's why we called you. And I was looking at your, online, and you have a pretty deep list of committees and technical experience, and I didn't know even what some of those groups were. It was new to me.
Yeah.
And I knew that we were bringing you over to look specifically at we're an OEM manufacturer, or so in terms of our equipment and the safety, understanding that it related to that, but knowing what they do is good. There's a couple other committees that you were referencing.
I'm on TC 76. I'm the secretary of Working Group 5, which is for telecom.
Okay.
So I'm an officer on that committee. I'm in 3 of the ANSI committees, measurements, telecom, and of course, facility assessment.
Right. There were some designations about, there's groups that, like, we're in class 4 lasers.
Yeah.
But there are other things, like you said, LED, there's medical, there's different groups. There were committees for those things, or there were.
I'm on the committee task force for LEDs. LEDs is a completely different hazard
Right.
than laser hazard. That's a photobiological hazard, and it's different from lasers. Lasers are a very narrow bandwidth emission. LEDs is a broadband, so the eye reacts differently to broadband. Like for these lights here, our eyes are reacting completely different than if they were lasers shooting at us.
So with these class 4 lasers that you're seeing, what are some of the considerations around that? I mean, what are you seeing? You're laying hands on these things firsthand, and what comes to mind?
Well, what comes to mind first of all is you have a class 4 laser that's in your hand.
That can be walked away from a unit about 35 yards, or
Yes.
what have you, 35 feet.
Yes, and you can wave it around. That's a concern.
And what happens how's that different from welding? Like if you move that thing out of a slip, it's probably gonna do something to it.
Right. So with these class 4 lasers that we worked with you today, it's very important that what's called the nominal hazard zone is
Spent a lot of time on that. That was interesting.
And what that is when you're cleaning a material with one of these lasers, the radiation will of course scatter and reflect. It'll be diffuse and broken up, but the closer you get to the working area, the more hazardous it is. And so what the nominal hazard zone is, it specifies the distance at which it's safe to be.
So think about that for a minute. We're not only in controlled environments, but these things are going out into the field. So conditions change. Joint occupants might be on a job site. You might be in a tank. You might be in a ship. You might be in a high-rise building, doing work. So nominal hazard zone is
crucial.
We were looking at worst case scenarios for every substrate, and wouldn't every laser be different, and every substrate would be different, right?
Absolutely.
Okay.
The nominal hazard zone is directly related to what's called the maximum permissible exposure, MPE, which is wavelength dependent. So if you're using a 1064 nanometer laser, that's going to, go into the equation for the nominal hazard zone for that wavelength. If you're using a UV 355 or a high infrared laser, changes the hazard zone. The power level changes the hazard zone. So the hazard zone is never set in stone. It has to do with what laser you're using and how powerful you're turning.
And if you're deploying these in the field, in the shop, ANSI has a standard of what's required, which is well, you're doing the same type of functions, the containment, the hazard zone, but in the field, ANSI doesn't make any distinction about.
That's a good question.
You have to set up a temporary to meet the ANSI so you have to evaluate your work, which could be variable, and do the same things and bring it down at the end as you're.
That's an excellent point. The ANSI standard is really geared for an enclosed area, like this room.
Yeah,
where we're going to use controlled and
shop work,
walls, ceiling, all that. But when you're going to use these laser cleaning devices outdoors, we can subject the requirements that are applicable.
Yeah.
But it's a little more difficult than if you were indoors. So you're still going to need to determine your nominal hazard zone, but you're going to have to set up some sort of a canopy or laser curtains or laser barriers around the area that's being worked.
And then deal also with, the other side is the laser generated air contaminants, which can be unique. So then how you're ventilating, how you're collecting what becomes airborne
then you've got
hazard.
Airborne contaminants are a concern, especially outdoors, because there are certain limits, and if you go above those limits, now you've got the EPA involved.
Yeah.
So Fume extraction is very important.
I that's a stickler to me because I sit here and, I was telling you, our even going through the, the process that what you're seeing a lot of is maybe a guy with an N95 mask on.
Yeah.
But laser hazards could be so varied, so different that it is not, that becomes a little bit more complex. But proper fume extraction might not even be a HEPA vac. It's it's the VOC capture, or it's whatever is appropriate for what you're working on. And I remember testing out different systems. If you're in a big shop, can you enclose the entire environment that you're working in? We were looking at some of the varied materials that even come in our facility, and I go, well, we built a laser room, right? But I'm bringing 40-foot things in here that we can only go around and how do we got a mezzanine. Somebody could look down on that. Somebody could, so you really helped us articulate those. A guy could be laying down on his back,
shooting it up this way, yeah.
And I'm shooting something for a big aerospace company, titanium, and you talking about hazardous. That all of a sudden I'm hitting this titanium alloy, and the reflection off of that must have been as strong as. So when we're talking about the reflection, scattered reflection, direct reflection, which is like considered just the same strength as a beam.
Yeah.
But guys are sitting here working on this stuff, and it might be aluminum or light, and the diffuse reflection it's not what I worry about. Like I said, I do worry about a direct hit, you're done.
Yeah.
And if I had to talk to another owner, what I worry about with my own employees is one of those, one miss, or one not using, engineering controls are great, but with what we're seeing, that's not always. You're doing procedural things. So not to get into the rabbit holes.
It kind of circles back to what you were saying about for these type of devices. It's not just like buying a tool. You have to buy like a program.
Well, I think the FDA would say that's regulated equipment.
Yeah.
And we looked at even the equipment builds. And nameplates fall off, and switches that can be, keys. We were
keys
looking
can
at,
come out.
So
while
we
it's on.
spent a lot of time going through builds and redundant. How does this fail?
Yeah.
What happens if you run over the fiber optic cable, and will it shut off?
Yeah.
What is it just a twist lock start? Can you remove the key when it's in the on position? Can you control access to the equipment? So you were so helpful in helping us really
thank you.
look at but we're seeing a lot of that, and I think safety is of critical importance. As this thing, it's on a trajectory, so
right.
you want to educate whoever we can about not only what to look for in a laser, but also the big aspect of operating it. And I would say we had this discussion in the room, right? And I could see you looking at I'm looking at you and you're looking at me and you're like, well, it was Steve from LaserMet. I'm at the FabTech show, and he drilled it home for me in his description of what happens. Right. So we go in they have these great enclosures and the interlocks, and you're getting two welders in there, or two laser cleaners working and they're going, and one guy's doing what?
Lifting up his mask.
Lifting up, like he'll stand up, look back at it, put it back down, go down, start working. And then you see that another guy might be still working, right? Like it gets dynamic. And so their control system does what? It shuts down. One guy lifts the mask up.
And that kills the power.
Somebody opens the door.
Kills the power. And the key, the touch of the LC, like the TV that's recording. Yeah.
All the activities, going on in there that's an ironclad setup. I
Yeah,
have to say.
that
But
would be optimal, if you could interlock this situation. But then again, we're now talking about, walls, ceiling.
yeah,
That's your best case scenario when you're working with one of these types of lasers within a room. We can,
yeah.
we can put in the engineering controls and the
That was the-
administrative controls. But outdoors, you still can, but it's just a little more work involved.
Yeah.
You know,
And I
really.
think that's what I would like to help those that are, you're integrating a laser cleaning. I mean, our focus as a company is for the clients that work in regulated environments, multi-trade environments, that have to integrate laser operations into their programs. And usually they have a safety focal in their organization, but the LSO and the safety training around the laser hazard needs to be, in my view, integrated into construction. And they would have these, that like, okay, well, you're working in confined space, fall protection, joint occupant hazards, things that you would see where you're bringing that onto a site that also may have other hazards. And the hazards around lasers they're quantifiable, respiratory, but the measures aren't always intuitive. Hot work, it can be considered hot work.
The reason I say that, it takes a little more work if you're going to be using this out in the field, outdoors, is because of passersby and onlookers,
Yeah.
When you're inside of a facility, you can control the doors, you can lock all the doors, only one guy is in there working. But when you're outside cleaning like a ship hull or a fuselage of an aircraft or a pressure hull of a submarine, and it's outside, you can set up your curtains and your barriers.
We're doing a lot of facade work. And
somebody could be walking by.
We're watching it, and we're shutting down the streets. We're putting the laser curtains up. We got the street, the permits, and then you're waiting 6 months for those things just to do a job. But we're starting to do larger facades, and we said, well, they're going to scaffold it. They're going to protect it, usually. So you might be working within an envelope on a large, but you're still inside that enclosure, and you're still looking at enclosing the area of which you're working and controlling the, like in aerospace, I work with.
It's not an impossibility.
No, but
it's just a little more work involved. Is
right.
What I'm trying to
So
say.
it's part of that JSHA and figuring things out. And at Boeing down there, I mean, everything's considered hot outside. There's no whatever you're doing. They want to make sure that airborne, or if you're in a big plant, that the airborne contaminants are not getting out into the joint occupant space. So they're looking at negative air. They're looking a lot at air and the hazards involved around it. But with that said, that's you're right. And we had to have security because people ignore. When you're shutting a street down, I was mind boggled. I was out there just lady. I mean, look, do you see these? Nobody, but so we actually had to have security just for one guy to get his work done. And contractors or folks implementing would also, it's kind of like sitting back and going, okay, Ken, how are we going to bid this job? Well, I'd say, well, put a little in over here and over there.
Yeah, and I and that's why I really like your approach to this. That you want to be able to inform users of the hazards and what should be done, and not just say, well, here's a really dangerous device. I hope you enjoy it.
Yeah.
I really like your approach to this, Ryan. It's a necessary thing.
I mean, you're seeing, what are we foreseeing here in the next 5 years? Do you think there's going to be an increase in laser
absolutely.
in the field on construction sites?
Sand is out, light is in. I said it years ago, copper's out and glass is in. With telecom, our internet is run on lasers, except for the last mile bottleneck, right?
Yeah, it took me
Copper's
a
out. It
second
used to
to
be all
digest that
coax cable.
Wow.
You know, really short bandwidth. But
Yeah.
now they can jam just huge bandwidths on multimode fiber.
Well, your
So
work,
copper's out, glass is in, sand is out, light is in.
like for this type of safety, it's your group. I consider you guys a tremendous resource for us. I'm thinking about engineered outcomes on, you hear me talking to you about, but if you're doing, like we're sending our samples of testing to labs, like, or we're metallurgists, or we're getting the profiles looked at, where we're quantifying the outcomes that we need to achieve. If you're gonna say you can etch some surface to a certain standard, you got to prove that standard, but you also have to understand that you're doing that with heat, and are you causing, you can get up there and say, well, something looks good, but you're understanding what's happening to the metal. So you could see my focus on this, and in all of our experience in our other divisions in infrastructure renewal and mechanical, and that side of it, I think about it being applied in construction. But your health and safety has been, is really needed for those looking to bring lasers out there. And it's not just, here's what to look for in laser equipment, of which there's probably a big swath that is not probably doesn't meet FDA requirements out there, but it's how, okay, you guys have a shop, you're a pipe fitting outfit, or you're a big sandblasting company doing work in-house, and you have trades over here doing A, but you need to laser over here. And that's a program. That's everything from air to the radiation hazards that you've helped us navigate. And it's not all intuitive.
It's a lot. I see this particular device, these cleaning devices, to just continue to be, to continue to grow in use.
Yeah.
Especially in the automotive industry, right? Restoration industry, of course, the cleaning of ship hulls and aircraft and submarines and
historical restoration, and woods itself
also
has its own hazards. A lot of people don't understand about the weird hazards that come off of wood, or it might look good, but if you're charring. So I'm thinking about it on that side. Yeah,
there's
but if you're overheating those fibers, it's not going to absorb stains the same way. Like scraping or sand, they all have different effects on the wood and the substrates and the hazards that come off, strange things coming off of wood in people's homes, or not to be, but it's looking at it on the front end, but that's definitely what are the I wanted to ask you, what are the manufacturer's responsibilities to bring, let's say you want to bring import lasers into the U.S. You're doing a few things. There's the 3.6. You're registering. You're doing some product reports.
You're going to have to do the appropriate measurements. You're going to have to do the appropriate testing. You're going to have to classify the product, classify the radiation in accordance with the specifications.
Okay.
Once you determine that, then you're going to have to fill out what's called a product report, and that's what we're going to be doing with
couple
your
of our
lasers.
machines,
and that product report gets filed with the FDA. The FDA issues what's called an accession number to that report, and that gives you the go-ahead to sell in the United States marketplace.
So you don't just stamp your decal on the side of it.
No,
you're checking the build of that unit, and the FDA is not necessarily digging in to check.
The FDA does not, when they issue their accession number, they put on the very clearly on the bottom, this accession number does not mean that we, the FDA, have approved your product. The onus is on the manufacturer.
I saw that on the bottom of the 2877. It says if you're not, if you're just, it was a federal
Yeah.
I mean, they had a statement on the bottom, and I was going, okay.
Yeah,
Well,
they don't approve
whatever.
it. They just say, okay, you've done your due diligence. You filed a product report with us. Here's your accession
And
number.
it's traceable.
And now they put it in their archives, and they can go back and look for it if there's ever any litigation involved. So, and they could possibly pull yours out and comb through it and
Sure.
give you a call and say, hey, explain this.
But they're also looking at, who's looking at the O&Ms to say this is a real O&M, that this is meets.
Well, it's
Who
the onus
has
is the onus is on the manufacturer, but like in our case, we would check your O&M for compliance. The requirements.
But is
are in
that
the standard.
ANSI or FDA that's saying
It
what
would be
needs
FDA.
to go?
The
Okay.
FDA, the 21 CFR.
Okay. And then from that standpoint, you're helping understand.
We assist
look at-
manufacturers with that.
Yeah. Operators have some responsibilities, which is also LSO, right? To document that the lasers, what you were telling us down here about laser inventory, or your authorized users and things.
Right. So how it works is after the accession number is issued, the manufacturer of that laser product is legal to sell his product in the United States.
So in our case,
Now-
we are doing a little bit of both. We're taking equipment and we are upgrading builds for FDA, like for solid FDA compliance in the US. So we're looking at the interlocks, we're looking at what's in it. And I know what we know what we want out of the lasers and how to build, but in terms of going, to
Does
get
it meet
that,
all the
yeah,
safety
but then I'm
requirements?
delving into, well, this thing has to run up there in the salt air, or it's going to be in these environments. And then that's the side I like, which is more the mechanical
the thing
engineering
that we should
side.
probably say is that the ANSI Z136 standard it's a user standard for class 3B or 4 lasers.
Okay.
Okay, so if you import anything under a class 3B laser, and then you sell it, and the user of that laser product, that ANSI doesn't come into play. Okay, you only need to comply with ANSI is when you are using a class 3B or 4 laser product,
Okay.
which is the case here with systems.
Yeah.
And so that's why ANSI
So the buck
is
stops
very,
then once does the FDA, if you put something on, don't they consider you the OEM of record in the US?
Sure, yes.
Like you can't, it's not, you can't pitch over to someone over, overseas. They're gonna
That's
stop
you.
somewhere,
It's
and that's
you.
with the seller. Okay, that makes sense. What are the users?
Now
Now you're using it. So now,
okay, so
put
now
that
let's
hat
say
on.
you buy a class 3B or 4 laser and you start using it. You're supposed to comply with ANSI Z136.1.
Right.
And if you just ignore that and there was some problem and someone were to get, there was some litigation involved, you would be liable for those damages because you just didn't do your due diligence and look into this. Anybody purchasing a class 3B or 4 laser needs to comply with ANSI Z136.1, and that means they need to have a laser safety officer on site, and they have to have a complete laser safety program written up and follow those standard operating procedures.
And we know that the LSO designation is kind of a starting point, isn't it?
It's just
I mean, it even
was.
it's like I'm going through it, and your team's, but they've got to run that program.
It's a name tag.
Yeah. Well, it's got to be.
Let's give you the name tag.
Yeah. So that's we see that it feels like that. If we could do one thing on those viruses is to help them integrate that into their programs at the least reasonable. I wouldn't say cost, but in terms of in my view, it goes out and it becomes reactive. Like you bought a tool, you love it, and they are incredible tools.
Oh, yeah.
Incredible tools.
Yeah, I was really impressed.
They're going to
with them.
change this industry.
Absolutely.
But getting it, for the mindset of those guys, a lot of the trades guys and the electrician, these folks they just have they have a good mindset for the use, but using that safely. And when things are reactive, number one, I think about safety reactive. We didn't know. Number two is what it's doing, how to use them properly on substrates, and I think that's being driven by the industry. There's no like I can look up mechanical standards in our HVAC division over there and know how you're supposed to do something, and it's growing fast. But if we could go, guys, we can help.
I like
you can help them.
That you can remove graffiti with these things.
Oh, you can. But
I mean, I'm not against graffiti.
Then the next thing they're going is, well, how do we bid this job? Like how fast is it going to go? How are we going to bid it? What kind of results are we? And I'm like,
I'm not
and then
against
you're going to
graffiti,
need 4
but
units
sometimes
instead of one.
they can put graffiti on a national monument or something. That's like, okay. So there's so many uses for these cleaners.
Well, I think what you're doing is fantastic, and that ecosystem. Whether this is going, and to educate folks, the faster we can do it, regardless of whether they bought somebody else's laser or whatnot, the faster we can help, the faster we can help inform the industry that otherwise, I look at, I have different divisions and stuff, and I go, well, what we've shelled out reacts to go, nope, that's not the right thing. That's okay. We're gonna, it can be costly to assemble after the fact. And
the way I look at it is safety has to keep pace with technology, and a lot of times safety is running after technology. Technology comes out and safety is close behind, trying to get up. The last thing we want to see in this industry is safety to lag way behind, and now we're going to see some incidents.
That's it. And what I worry about is not sure. I worry about a drastic laser injury, but what I was telling you, it's no. It's that over time, that exposure, or getting where you're getting the whiffs of over time airborne contaminants, or you're leaving them in the space. There's some things that are immediate hazards, but what I worry about is are these things right?
It could be a chronic hazard that we got. You think of an acute hazard and a chronic hazard.
Right.
That's something else. That could.
Well, there's a lot of work to do out there, but it's just been. I'm so happy to have you in our orbit, and I think
Well, same here.
Helping people with the equipment, the operational hazards, getting a program put together efficiently. It took so much stress off of me because it's the late night work. I used to work in this cave right here, at night, jamming away on this, and then trying to run construction in the day on other things. And
I understand.
And
that,
this made it so much just.
Well, we're here to help.
Easier.
We're protecting the public. That's the important part.
Thank you, bud. Appreciate it. You did a great job, and let's keep going. And there's more work to do out there. And thank you. I appreciate it.
You're welcome. Thank you.
So.